when we're looking at this, essentially, you know, reverberation, you can see the model down here, this little view. Let me get this out of the way, actually. One of the things that you should be aware of is reverberation is part of your everyday life. Now, I was just talking to class on Wednesday. It's kind of interesting. So, like, you know, even when we talked last week, we talked a little bit about the consistency needs. But when I'm walking down the hall, okay, so let's just say I go down the hall, down to the end of the hall, and you go to the other end of the hall, and I start shouting to you information. The most important thing that your brain processes out of that contact is not, oh, wow, listen to the reverb. It's not, oh, you know, listen to the tone of the voice as it's transmitted from, you know, 100 feet across a hallway. No, it's, if I said, hey, meet me at so-and-so at such and such a time, your most important thing is, what did I say? Yeah, the detail. It's about the detail of what I said, right? The detail is what I said. When we come down to musical content, though, a lot of times our brain processes that information very differently because our brain is not required. It's not if a song was a step-by-step instruction on how to live your life, maybe it would be very important for you to hear every word. But instead, a song is typically some sort of emotional journey that's trying to take you on, and it's not just about the words, it's about the culmination of everything that's going on and how it's all pieced together. So when we look at reverb in a musical form, all of a sudden it becomes very important and very transparent how much reverb is either there or is not. Whereas if I ran down the hall and I said, hey, how's it going? You, like, literally, like, if I just did that, you'd probably say, oh, that guy said hi to me, and that's your thought process. You didn't think a second about the acoustics of the room. Right? You follow me there? But once you put it to some sort of recorded medium, all of a sudden it becomes highlighted and you're like, oh, wow. But again, you know, it kind of comes down to what's the importance of the content. The importance of the musical content a lot more times than often it essentially is the emotional conveying of something artistic, right? Now, that brings us down to how we're going to use reverb, why we're going to use reverb, and just some basic elements of reverb. Now, I'll tell you this. Reverb, when you're singing in the shower, reverberation is the exact reason that you are the next American Idol when you sing in the shower, right? And as soon as you step out into a room like this, you know, it's very different. The worst, I mean, I don't know if some of you guys are musicians. When I was in high school, I played many times outdoors in the cold as part of marching band in the rain. And the worst case scenario you could ever have is either in the rain or in the snow or in freezing cold temperatures where your sound does not necessarily travel very well because of the climate. And it's a very dead feeling, you know, with no amplification at all. It's a very dead feeling, and you know it. If you've ever experienced it, you know what it's like. You know, I mean, it's very difficult to project. And the thing about it is when we're in our nice, warm, controlled environments, and we have these kinds of things going on, a lot of times what happens is there's energy or excitement, resonance that's built. So like you go hum a tune in the bathroom, there's all this energy that's brought to light because of the reverberation. This is something we need in our recordings. That's something we need in our recordings. Does that make sense? However you get it, whether or not you record in a really controlled environment and then add reverb in the post, or if you record in a very live environment, and then just tailor that live sound by using things like room mics. Last week I showed you guys some drum recordings, and we had some room mics that added way more of an ambient tone. One other thing we could do is we could use a special type of mic that we all know and love. Not really love, but you guys know what I'm talking about. There's a mic that's designed for capturing the ambience of the room. What was it? You guys remember? Specifically designed for capturing the ambience of the room. Yes, the figure 8, which is assigned specifically to... Well, okay, it can be used on the condenser. Go back more old school. The ribbon, right? With the ribbon, which was ideally always designed in a figure 8 pattern, captured that roomy kind of sound. Now, problem with reverb. So I would jot this down. There's a problem with reverb. Warning, problem with reverb. If you recorded something with reverb, it's very difficult to eliminate it. Now, you should have read in your processing chapter, the processing chapter that you guys had experienced, should have mentioned something about gating. Right? You guys read about signal gates, signal gating and the processing. You can gate something that will essentially, minimize the amount of reverb that's being displayed through the content. The problem with it is that it forces you to have to do that, use that process if something has too much reverb on it. Does that make sense? So a lot of times that's the reason why when it comes to actual recordings and when it comes to working on actual recordings, we prefer to have them be drier at the recording process so we can make the decisions later about how much reverb we want to add. Does that make sense? The other thing that we get from reverb as a bonus, and then we'll jump into these because I need to actually get through the slides, as a bonus, and a really helpful thing is reverb tends to glue things together that were once separate. And what we do in a mix is we usually generate one reverb that everybody is put into or everybody gets involved in. I like to use a reverb, separate reverb for the snare. I'll use a separate reverb sometimes for like a lead vocal, some sort of signal chain, and then everybody else gets put into one batched reverb. A lot of times the snare has its own verb sound, and that's why we go that route. A lot of times the vocal may have some sort of special effect verb, and we go that route. And then maybe we use delay or things like that in addition to. So one of the things that we have to look at is reverb kind of glosses things over so that they feel a little more smooth and a little more connected. Because if I were to go, okay, and this is the problem. In the 1950s, if I had to record us as a group, I'd drop one microphone here, and I would record it. In the today's, if I told you that this is how we're going to do it, most people will go, that's probably not a good idea. You're not going to have as much control over the balance between everybody. The big reason is if we all sing We Are the World, okay? We all sing a song together. You could be louder than you, and you could be louder than you, and you could be louder than you. The problem with it is that in most cases, you're not always going to be consistently louder. You might just really know this part really well and it's in your range. So for this one phrase, you're loud, and for this next phrase, you're loud, and for this next phrase, you're loud. And the inconsistencies of it, when we only have one mic, makes it really difficult for us to do anything after we record it. It's like whatever we got. How you guys sounded in this room is how it's going to sound in the end. But if instead, in the modern style of recording, I give everybody their own mic. Okay, follow me on this. Everybody gets their own mic. We all still sing it together live at the same time, but everybody gets their own mic, and by having their own mic, I can control a little bit of the balance between the two. Now, there's still going to be bleed if we're doing it live from the neighboring people, right? And if I got one guy back in the back that's super loud, he's still going to have a lot of volume on the person over here, on their particular mic. But it still gives me the opportunity to make changes in the overall balance. Now, let's take it to the next step. If I said, man, that's great control, but we could go one step further and just do it individually in a smaller controlled room. And everybody gets mic'd up individually. We're all singing like we were a group. But all of a sudden it gets brought down to this really small feeling. The problem is then when we put that in the mix, we bring everybody's vocals all together, it's still, what it sounds like, to be honest, is it sounds like my ear is right on somebody's voice. And it's your voice and your voice and your voice. It's everybody's voice. Does that make sense? And that's really kind of uncomfortable. You know what I mean? Like I've heard mixes where the vocal was just so far forward. It was like I'm not really like very comfortable listening to this song because yeah, exactly, very close. Like I feel like I'm like I can hear all the spit moving around. That's a little too much for me, right? So what happens is what we do with that is then we do all this miking for everybody individually. So we can do all the balance and we can say, look, the part you sang at the chorus we don't like enough, we're going to get rid of it. But we're going to use your part over here instead, things like that. And then, of course, once we mix it, when we blend it, we add some reverb. And that reverb is going to ideally make it sound like we're together as a group. Does that make sense? The other thing it also does is it kind of hides the rest of the imperfections. We may have dynamic imperfections. Those will be handled by dynamic processing. So compression and limiting are going to handle our dynamic imperfections. Auto-tune is going to handle all of your pitch imperfections, right? So we'll just go ahead and do that, throw that in there. And then, of course, in the end, in order to make us still sound more consistent, we're going to add a reverb. And that's kind of why we would have it in the recording process. That's why it's such a big part of the mixdown. So let's talk about a couple things. Although I think, hold on. Let me just make sure this has, oh, good, okay. Let me go back. I want to show you this real quick image, if I can find it. There it is. Okay, this you saw a second ago Sound source, listener. The dry signal is essentially direct from me to you. What we call early reflections are anything that might hit a boundary and return to you before the actual reverb. So by definition, okay, you just jot this one down, okay? By definition, reverb is a multitude of reflections. You know, thousands of reflections, millions of reflections. You know, I mean, it's a multitude of reflections. And that's kind of the key here. Reverb is a multitude of reflections, where if I said, no, I want to make an echo sound, I want it to go, hello, hello. That's called delay. Why? Because when I said hello and the echo came back, there's only one reflection. Follow me there? So delay is singular. Delay is singular items. Hello, 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 hello. Individual reflections. While reverberation is a multitude of reflections. So, and that's how we identify that. But in that multitude of reflections, there are also early reflections. Now, if you were to just do the math, just some rough math, you're sitting mostly kind of in the middle of the room. So let's think about it, okay? Let's think about where he's sitting, and let's look at the reflected points in the room. Where do you think the farthest reflections are going to come from for where he's at? Yeah, the farthest distance, right? Where do you think an early reflection might possibly come from?
That music stand.
Yeah, the stand, the board, right? That stand right there, right? Anything that's close by. Does that make sense? What it does is that the early reflections are essentially a grouping of reflectable points that happen earlier than the majority. Okay? Now, the big key here is that, you know, what kind of materials we see, and it's funny because, you know, when you're in construction or when you deal with construction, you realize, I think most people don't realize until they get into it and they kind of look at it. Most of you probably haven't had a whole lot of construction background. But when you're in construction, you start to realize that in commercial construction, there are sound requirements for what kind of stuff they can use material-wise in a standard room. Now, luckily we're in a studio, but if we were just in an everyday classroom, there are requirements on a construction level that tell them what kind of texture they're supposed to use, what kind of ceilings they're supposed to use. You follow me so far? What kind of materials are allowed to be on the walls in order to offset the amount of reflective points in a standard room, so that if I was standing up at the front of the room and I was trying to deliver a lecture, you in the back could actually hear me instead of hearing a bunch of multitudes of reflections. A lot of times the easiest fix for those, you see them everywhere, carpet. As opposed to linoleum, right? As opposed to any standard hard surface. The other thing you also see a lot of times is you see a lot of, well, in this, obviously we have diffusers up here, diffuser panels, but a lot of times you'll see in a lot of other rooms, you'll just see general panels throughout the room. General random, you know, assemblies of panels. Really funny thing, because if you think about reflective points and sound and all that kind of stuff, you may have not known this, but if you've ever been to a live football game, stadiums are required by legal regulation to have a decibel rating for the stadium that does not exceed whatever OSHA says is acceptable for the human ear at that kind of a location. Which means that when a stadium's filled with, you know, 50,000 people, it cannot exceed a certain volume if everybody gets excited. So they have to do a lot to offset that, make sure that there aren't, you know, because you think about it, like if we're in a bowl type stadium, all the reflective points, as soon as you hit the outer boundaries, kind of point back in. And so there's a lot that they have to do to offset that. But again, it's also based upon, you know, how those reflection points are designed. So in everyday life, you see that. Now, when we look at, anybody used DAW and you've seen a reverb, digital reverb before? Okay. When you look at those, the way that they're designed essentially is the companies will go out and they'll measure those points. Like if I wanted to mock up what it sounds like to have reverb in this room so that we could make it a software patch that you could take home, all I would do is drop the source back in the middle, do some tests, put some mics on the boundaries, and what I'm looking for is I'm looking for what's the signal source. What frequencies were put in at the mic source over there, over there, over there, over there, Essentially, how does the original source do, and how does it translate to the mics that are collecting them, and how much of a difference in space is there? You know, and that's how the algorithms are designed for these reverb devices. So let's talk about this. Oh, we just talked about reverb versus delay. So hopefully you're reverb versus delay. Reverb is the multitude of reflections. Delay is singular reflective points. Okay? Really big key here. We really don't get a ton into delay. Sorry, did you still need that?
I just have a question.
Yes.
So like, have you ever been walking along and maybe there's a domed room and all of a sudden you start hearing yourself like really loud and really, is that delay or is that reverb?
No, well, if typically it's reverb as opposed to delay. You're
Yeah, because you kind of hear an echo. You're like, oh, am I echoing? No, this is just weird. I just feel like everything sounds weird. You know what I mean?
Yeah. Yeah, I think you know, the one effect that or phenomena that you see that gives you a distinct delay feeling is like that standing up on top of the Grand Canyon, going hello, hello, hello. You know, but what happens there is a little different than what you get in a normal environment, and like what you're describing is still typically reverb because there's not enough individual reflective points for you to very clearly identify it as a singular item. You know, versus a lot of times it's still in groupings. And they can be closer or further apart. And that's kind of what this grid shows. It's kind of interesting. This is loudness over time. Each one of these is a reflection. And what you'll see is here's the original source. Here are the early reflective groups. So notice they're spaced out a little bit further. But here's the reverberation. Here's the multitude. But notice it's, of course, dissipating over time. And what you could see is even in early reflections, you can see groupings of early reflections take place, almost feeling like a phasing effect when you're talking just kind of naturally. Yes, sir.
But you can't have a delay without reverb.
Yeah, well, you could. I mean, typically no, because in a natural environment, typically no, because the way that it works, you would have to hit a flat surface head on that would only be a single barrier with no other barriers parallel or running parallel to each other or perpendicular to the reflective point. And then it has to return to you in a very consolidated way. The problem with it is that when you talk, like let's just say
Doesn't it lose energy?
it does. And that one of the big things is that over time, over distance, essentially, it dissipates and gets absorbed by other things. But if I were to just turn and face the board, even if I was standing in an open field, there's not enough energy for it to necessarily reflect back as an individual delay. And because it's so close, and this is kind of the other catch, okay? So there's a rule. And you should have read about it. I'm pretty sure we had talked a little bit about it. There is a rule called the Aux effect. It was in your book. The Aux effect, so this kind of makes it more difficult. The Aux effect basically says anything within 30 milliseconds of a delay is not perceived by the human brain. So anything inside of that 30 milliseconds is filtered out, which means that like I can't stand in front of the board and get a delay effect or even hear my reflections off the board if I'm standing really closely. You know, because the delay time isn't there. It's not 30 milliseconds of delay time. In order to get 30 milliseconds of delay time, I'd have to stand in the back of the room, but then by the time I get that far away, there's not enough energy for me to even hear it come back. Does that make sense? So it makes it kind of difficult. You have to have a loud enough source, and it has to throw kind of far, and then again, it has to hit a boundary that won't then bounce off other boundaries, because as soon as this boundary isn't the only boundary, it will then reflect off of here, and go there, and then of course, then you have a multitude of reflection points, and there you get reverberation. Does that make sense? So yeah, it's very, very difficult to do. Yes, sir.
So you said for old recordings, the reverb would come just from the room. I know they would do like stuff to tape for delay. What would they do to that? Like how?
Well, there are a lot of techniques that they use for delay.
Yeah.
But I would say the most archaic was literally shooting audio down a small, narrow channel. You could use like a cylindrical tube, or you could use like a box. The original reverbs were built in that kind of concept too. I mean, you literally, like, you could take a box that was the length of this panel here, and the idea is you'd have to channel audio through it in order to generate some sort of affected delay. But you actually had to kind of like make a physical device or a physical path. It made it very difficult. Like even in the opera days before amplification existed, means for that is they would literally, make brass or metallic bells, and there were lots of different designs, tubular kind of chutes. But like if you think of like the bell of a tuba, they would just literally put a bunch of those, a whole wall of those in the back of a room to kind of redirect and add reverberation where reverberation didn't exist and add amplification or energy to the overall sound. So yeah, a lot of the natural effects. I'll say this, they were not very effective. And they were very difficult and cumbersome. You could go, I'm pretty sure Abbey Road still has their original plate reverbs, and if you look them up online, actually I bet you if I looked, we could easily find it. Because that's, some of the old school versions of how reverbs were designed then. Now they're digitally generated by logarithmic calculations of what it would sound like. Literally, all it is a copy of the original sound. Like if you think about it, if I said, "Hey, reverb's just a multitude of reflections," what you could do with that is digitally, you could just copy the source, thousands of times, and by giving it different timing mechanisms and delays, essentially it's a multitude of delays that make up a digital reverb. But if I just let's see. Whoops, Abbey Road. Let's go, video. I think this video might have it. We'll see. Sorry, audio's overheard.
Guy Massey, welcome back to Abbey Road Studios, and thank you for joining us today.
Pleasure. Nice to be back.
Yeah, there they are. I think I can see that room in the light.
We're here to talk about the Waves Abbey Road plates.
Yes.
And we have 4 plates here at Abbey Road, which you're pretty familiar with. You've seen some action with them over the years, I believe.
Yes, yeah, quite a long time ago, but 10 years I was here, so most sessions we would definitely plug them up if the classical boys would let us have them, which wasn't often. When I started, I was probably assisting for about 5 years, I guess, and I was working with John Leckie, and we worked on Radiohead's The Bends, and he mixed that in here. It subsequently went on to be sort of some of it remixed, but he would always use the plate, or a plate. He would have 1 or 2 of them going. I did Ian Grimble on the Manic Street Preachers' Everything Must Go, and that was lots of reverb on that record, and that would have been the plates for sure. And we probably had the chamber, Two's chamber, hooked up as well. So, and then everything subsequently, when I became engineer myself, a lot of the Beatles stuff that I did, I would have definitely used the plates for when we did the anthology. Paul Hicks and I, we were in Studio 2, as you know, for a long, long time, and we would have used the plates a lot there. And when I did Surround for Help, I would have definitely used it. Probably not, really up front, but it would have been in there for sure. So every session.
I was thinking back to before the plates came on the scene here at Abbey Road. 1957, I think they were first released out to the general public.
57, yeah.
Yeah, Abbey Road bought 4. Now, before those plates existed, your only option to change the sound of your recording acoustically was to use an echo chamber.
Yeah.
And there were 3 echo chambers here in Abbey Road, Studio 1, Studio 2, Studio 3. They each had their own dedicated echo chambers. But that's obviously bricks and mortar, right? That's like 4 walls and a microphone and a speaker. You can't change the reverb time as such. There's not much you can actually play with. So before the plates, your options were really limited. I mean, the chambers sounded absolutely amazing, but they are, they were what they are.
So yeah, it must have been quite shocking in some ways to be able to manipulate sounds in such a way, or put them in spaces that maybe don't exist, as it were. So I guess having 4 here that do sonically sound quite different.
So I'm just going to pause this for a second. I guess you guys can see this. So these are vintage plate reverbs, and what happens is the signal essentially is sent down metallic plates. And I don't know if you guys have ever been around metal, but if you're familiar with like that in one way, shape, or form, like the way that metal reacts and it vibrates, what they do is they're able to dampen it or make changes to what's going on in the internal guts. But essentially, there's a signal source being generated off a speaker, and then on the other end, there's a microphone capturing that reverberation from the box. What they were talking about before there was before the plates, and these are huge. But before these plate designs, they literally would just use a real space and throw up speakers and throw a microphone on the other end, and that's how they generated reverb. You know, so they do the final mixes, and they route that kind of the final mix elements down there and re-record it back in, and that's how you get that reverberated sound. But these essentially are old school plate verbs. Obviously now, I think there's a one in the rack here. Yeah, here's a digital reverb up here at the top. It's the Yamaha, and you know, I mean, even my phone, you know, has reverb on it, you know, and of course, let's see, we go back to, you know, just basic GarageBand kind of things. I'm gonna jump out of this. You guys can check out some more of this if you'd like to. I need to talk a little bit about some concepts and some elements that go into what makes a reverb, or verb as a lot of us call it. Go, go, go. Okay. All right, so when we work with these, I would jot these down. When we work with actual devices, the components that we see on a standard reverb, our first one is called pre-delay. Sorry, this automation, I should have shut this off. Come on. There we go. Pre-delay, this is going to be a component that you're going to want to know. This essentially is the amount of time before an early reflection begins. I wanted to see if I could get on the master. What do we got here? Track. So essentially, pre-delay is the amount of time before the early reflection begins. So it's essentially pre-delay is the gap before the reverb starts, before the early reflections of the reverb starts, so before your first callback. Adjust the position of listener in the room. So the big thing here with pre-delay is an easy factor that just differentiates the difference between if I said I want the reverb sound of me being in the studio, or if I want the reverb sound of me being in the hall, or a reverb sound of me being at a pool, or being at a cathedral. It's really the makeup of the timing mechanisms. Does that make sense? And I want to show you these. I'll have to jump to Reason just so I could show you these a little bit. Early reflections. Of course, define the repeats of the initial sound. Those are the ones that are a little more identifiable as individual things. Early reflections, based on the timing of this is if you want a more 80s sounding kind of reverb, heavy use of early reflections is very popular. And it really kind of gets you that kind of slap effect, a little more immediate, and a little less drawn out, a little less live stage cathedral kind of feel. Does that make sense? But again, I'll show you some of these sources and how these change. The big thing here, and I don't know why it. Oh, okay. The big thing here, decay time. Decay time above all these other ones is by far the most important. Decay time is how long this thing, when you saw that little graph that did this, decay time is how long it takes to go away. Okay, how long that reverb takes to go away. So it doesn't clearly define it here. should have, but how long that reverb takes to go away. Here's the big thing though, okay? And this is what I always stress to people who are working on this. So we talked a little bit about automation. We didn't really say, hey, like this is how you do automation, but we talked about the fact that automation is when you go in and you have to write a parameter that has to change throughout a song. The worst thing you could do, if any of you are thinking about being an audio engineer, live especially, but an audio engineer at all, if you wanted to do audio engineering, remember that audio engineering is not a set it and forget it kind of thing. The beginning of a song, the opening phrases of a song have a sound, and that sound needs to surge into the next section of the song. But once that next section of the song clears, we got to go somewhere different. And because of that, a lot of times we have to go manipulate and adjust. Like we can't just like, oh, this is the volume of the drums, and they're going to stay the volume of the drums the whole song. We have to do some adjusting along the way. Part of that, though, is also with reverb. And the big thing is if I'm, like, let's say I start a song, and it's just me and an acoustic guitar. I'm singing in an acoustic guitar. The amount of reverb needed for me and an acoustic guitar is different when it's just me and the acoustic guitar than it will be once I add everybody else in the band in. And the reason why is because the decay time, which looks like this, I mean, I'll just simplify it, but this is your decay time, right? When you think about your decay time, so your initial source sound, and you think about your decay time, if the band is playing at this volume, do you even notice this amount of decay time? Let's say we said the decay time's in milliseconds, but let's say we set up a 50 millisecond decay time, and about halfway, at about 25 milliseconds, we hit that volume where the rest of the band is at. We will realistically, while everything's going on, we'll only hear 25 milliseconds of that decay time. Does that make sense? Because of that masking effect that takes place just in the overall volumes of things that are going on, that means and requires that while everybody's rocking at their fullest, a lot more reverb is needed. A lot more reverberated decay time may be needed based upon what is supposed to be transpiring. So like, this happens all the time. Well, actually, you know what I have? Shoot. I don't have a system set up. I don't know if I have that session. Well, let me see. The session we worked on, I showed you last week. Just don't know if I have the, let's see. Okay, I do have it. I just don't have a sound system in here. It would take me a moment to plug one in. Let me just see. You might be able to get the gist of this. Oh, this might be before drums. Oh, this is before the drums. Oh, darn, that stinks. I might have to bring up the session so you can see it. I have it on here, so maybe that might be the best thing to do. Essentially, what I was going to show you is that I have a session where it's just the drum, almost just the drums at the beginning of the song, and they're big. They're like, right, and that's beautiful. As soon as the band comes in, all that stuff gets eaten up, and all of a sudden it just sounds like boom, because in the decay time, this is what happens. Does that make sense? So essentially, the volume of that decay, because the decay is essentially going to descend. Now, there's some things that we can do with it. There's some things that we can do with it. So this is just a little bit off the slides, but a little bit of food for thought for you. One thing that they heavily worked on and developed and did every experiment they could think of in the 80s, which is the 80s was like the iconic reverb development time, was they were like, you know what? We have a problem with this. There's an issue with this. And so what we're going to do instead is let's do this to clean it up. Oops. Let's create a gated reverb. Now, again, in your book, you should have read something about gating. Gating essentially is a process, we didn't get to really go over it very thoroughly, but it's a process of which there's an automated system, and just like in compression and limiting, there's a threshold. But in compression and limiting, what happened when we reach the threshold?
He brings it back down.
Yeah, kind of. When we reach the threshold the first time on the way up, what happens? Reach the threshold, what begins?
It's activated.
Yeah, essentially compression begins. But before we reach the threshold, there's still sound audibly going on. In gating, There's a couple ways to gate. You could hard gate, which means essentially it's an automated process. That means that the audio is technically shut off until the threshold is breached. And when the threshold is breached, all of a sudden the audio turns on. Very effective with drums, very effective with vocals and certain, not vocals, but like dialogue in certain instances. But they also use it in another manner where instead of it just being shut off, it actually just is turned down. So like when it's not really heavily in use, and it's not loud enough to breach the threshold, it's just turned down. When it breaches the threshold, it fires up. Well, in that idea, what they did with the reverb is they said, hey, let's just do this. Realizing that there's 25 milliseconds in this image that I put on the board, there's 25 milliseconds of unused reverb. Meaning it's in there, but it's kind of just in there floating around, making things kind of muddy. So what they would do is they would just say, all right, well, here's what we're going to do. This line is the band, overall volume, and guess what? We're just going to take that same volume and we're going to add a threshold for our gate. And basically what it's going to say is until that reverb reaches this point, it's not going to be audible, and then once it does, as soon as it reaches this point on the way down, it stops. So that essentially they could have more and more reverb. You know, you could stack on more reverb front-loaded, you know, towards the initial sound, and by gating it, as soon as that sound got below something that was really audibly heard, it would just go away. Again, making it cleaner, making it crisper, also making it somewhat shorter. There's also something that they also started doing, especially with snare drums. And what you would do is you would actually take that, you would take this reverb option, and you could literally, instead of doing it like this, you could build it as a gated reverb that had a more solid fixed amount of time and barely decayed at all before it was shut off, which would make things a lot bigger in just overall image. Sorry, did you have a question?
Yeah, what's gating? What is that? I don't get that.
So the gating,
Oh, yeah, go
the
ahead.
the gate in the process is essentially it's like an auto on-off system. That until something's loud enough, it just doesn't bother turning it on. So it's almost like I have to talk at a certain level before my signal is allowed to be opened up. So that it's like a gate. They call it a gate. They call it open and closing the gate.
I was thinking of gate like like stutter like gates, like how it does this.
Yeah.
Effect.
Yeah.
Like that. Is that the same
That's
thing?
it's the same thing
It's just
because
used in a different.
yes, and it's using it in a pattern base.
Okay. Gotcha.
Yeah. So but yeah, it's kind of the same thing. It's just an automated process of when to open and when to close.
Okay.
You know, and that's kind of a newer technology that, I mean, that's only been around for like last 5 years or so. You know, doing it in different styles and such. The other thing is, one more parameter here that we should talk about is diffusion. Diffusion, when we talked about diffusion before, we talked about like these are diffuser panels above your head. We have some diffuser panels along the wall. What's up? What was diffusion? You guys remember? Diffusion. Okay, not exactly.
Get the sound to stop bouncing?
Okay, not exactly that either. It does something. Diffusion, you guys ever heard of a light diffuser?
Yes.
What is it?
It's like a, you know what a gel is?
Yes.
A piece of plastic. Well, I don't know.
Okay, yeah, so a
But
piece
it's
of
like
plastic.
it goes in front of a light to change the color of it. And then diffusion is basically clear, but it's very like cloudy and foggy, so it makes the beam of light spread out more, and you can't see like the edge of it.
Yeah, I mean, that's the easiest way to think if you're ever like, I forgot what diffusion was. Think about a light diffuser. Light diffusers, essentially, these don't have light diffusers, which is why when you look up there, you're kind of blinded. If it had a light diffuser, what it would do is it's essentially like she's saying, it's a cloudy piece of plastic, and all it does is it distributes the light more evenly instead of having it be so focused on the individual lamp. It's the same thing with audio. It doesn't, I mean, you can make, just so you know, you can make a diffuser that's absorbent. But in most cases, if you were to go knock, these are diffusers, you go knock on them, these are diffusers on the wall, they're hard as a rock, you know what I mean? Like, diffusers are not intended to absorb, they're intended to redistribute in an even manner. So the whole goal, and the reason why those diffusers have ridges, is they're actually measured out to match room frequencies that may need to be redistributed to make the room more even. So like you can see these ones have really deep notches. These ones have really small notches. But you'll see crazy versions of diffusers designs. And diffusion designs, essentially, you're ideally just sending the signal back, but instead of evenly doing it as a flat surface would, it's going to break it up. And based upon the depth of each one of those nooks, the frequencies respond differently, and then they're redistributed back in a more evenly way. Now, a real easy diffusion, like the most, or diffuser, the most simplistic diffuser looks like this. And in the diffuser, when the signal comes here, it essentially, well, I'll say when the majority of signals come here, it redistributes them outwardly. So the absorbing, they make a kind of absorbing diffusers, and what they are is they're foam, but they're literally rounded foam pieces, or like a half moon, foam pieces, both absorbent and diffusing. But in most cases, you're going to see these kinds of styles. Now, how does that work with reverb diffusion? Reverb diffusion just means that, like, how I was saying, hey, reverb is made up of a multitude of reflections, right? If I make my multitude of reflections come right off of this flat wall, the expectation is they're going to be pretty undiffused. They're not going to redistribute very well. They're literally going to come back as a direct copy of what I did. In diffusion, the goal for reverb is to redistribute the frequencies more evenly. And the good part about that is, I say the good and the bad, really. The good part about that is that an overabundance of mid and high frequencies kind of gets smoothened out a little better in diffusion. And the downside to it is that if I run a kick drum in a reverb situation, a lot of the low end just doesn't get generated. Like, my expectation is not that I'm going to have a lot of reverb down in the sub-frequency range. A lot of times it all goes to the attack side. So, but again, the way that it's diffused is very important so that it has a nice balance, a nice broad natural balance. That's why when you look at reverb, once you get into it, once you get very, very comfortable with it, you realize some reverbs just are very bad in quality. Most of the time they don't include things like diffusion settings. They don't include really well thought up variable decay and pre-delay parameters, where the higher end ones really give us that ability. One other parameter that's added here is density, which defines the space between the early reflections and the reverb itself, between the small groupings of early reflections and then the large body of reverb. You guys okay? Hanging in there? And actually, I want to show, let me see how much. Okay, so we talked a little bit about plate verb. I'm going to jump over to, actually, I will say this. Some old modern reverbs still include something called damping, and essentially it refers to how sound reflects based upon the construction of the space. What a lot of times they'll do with the reverb device. Well, okay, let me just say this. Okay, I'm going to get really loud, and if you listen to the reverb of the room, try to isolate where the frequencies you hear essentially are. Okay, so hey, hi there, how's it going? Where are my frequencies at balance wise when I start to hear reverb kickback as it starts to get excited?
Can you do it one more time?
Yeah, I can do it one more time, just for you.
Like up on the side almost?
Okay, yeah, I mean from here it feels like it's over there. Let me do this. Okay, let me see if this helps. Hey there, how's it going? Can you hear me? What kind of frequencies exist in the reverb?
Really ridiculous ones.
Yeah, really ridiculous. Exactly right. Ridiculous ones.
The lower one sounded like it came from all around, whereas the high one sounded more like it was coming from a specific place. Like
Okay.
Back there or back there.
Do you remember why that is?
Diffusion?
Well, no, that's awesome. I'm glad you got it because, I mean, here's the thing: low frequencies, right? They radiate.
They can travel further.
They don't travel as far.
They actually don't. They don't travel as far, and they require more energy because they radiate at 360 degrees. All right, so like the lower in frequency you go, I mean, I'm not saying that like when I'm down here, that's 360. When you go to sub frequencies, they radiate at 360 degrees because they actually need a reverberating body to be generated. So you know, I can't expect a mouse to make a sub frequency, right? Because just the resonating body of a little mouse just doesn't have the sheer size to generate that kind of frequency. Where if I brought an elephant in, I could probably get really low groaning sounds. You know, but essentially what happens is in the low frequencies, they radiate at 360, and the mid frequencies and all on the way up, they become more directional, which is why the reflections become more directional. And what happens is that the problem with that is that anything, low frequency generating, high frequency generating, when it begins to generate reverb, what it tends to do is it tends to shift towards the highs because they're so directional and they have a lot more energy. So a lot of times we use something called, bless you, something called damping, which allows us to filter the high frequencies so that they sound a little, we essentially filter them out so that they sound a little more natural towards the original source. Well, I mean, a really great example, which I'm assuming is back here, if the drums are still here. Yeah, I mean, here's a really good example of this. I'm going to open this up so you can hear it. As simple as it is. I'm about to kick a kick drum. And I want you to know that if you were to put your ear at the kick drum, you would actually hear sub frequencies. What do you hear out there? Other than this low tom.
Yeah.
The sustain.
What's that?
The sustain of it.
We hear like higher tones.
Yeah, essentially. Well, yeah, and you do hear the sustain. I mean, it's pretty wide open in terms of, but you hear higher frequencies because of your distance and proximity to it, right? So if you were to really get in there, you'd hear all those low frequencies.
Yeah. It sounds like what's like leftover.
Yeah, okay, and it seems really hollow, kind of for a kick drum. You know, and I mean, that's why we're going to have, and it's really interesting, that's why we have to have some frequency controls on reverb, because even reverb in a natural state sounds like that. And a lot of times in a mix, we might want it to not sound like that. We might want to, I want to have big sounds, I want to have a long decay, but I want it to sound full all the way to the end, so I'm going to have to offset a little bit of the EQ curve of the reverb in order to make it get that sound. Does that make sense? So there's a little bit of contouring that has to take place. I will say this, I prefer, as an engineer, I prefer to run my EQ, my reverb path so that it goes back down an individual channel and I can process it the same way I would process an original source. Not identically to the source, but that way I can go and add compression to my reverb. I can add gating to my reverb if I wanted to. I can add equalization to my reverb so I can tailor the reverb. Because in most cases, there's a lot of reverb going on, and it makes the overall tone of the sound. And if I start to EQ and change that, I can actually get rid of some points in the frequencies that maybe are hiding or masking other things that are going on. Happens a lot. So it's kind of nice to have that kind of control. Oh, sorry, I ran through that too quick. Sorry, this isn't set up to sound, so you can kind of hear this a little bit.
Reverberation. Chamber reverb.
Hear how long the decay is? How long it draws out?
Plate reverb.
Much brighter. One of the problems with plate reverb is that it's built upon metallic plates. The problem with metallic plates is they tend to sound brighter and tinnier. So the downside to it is we couldn't really effectively throw low end down it. Now, room reverb is very common and very heavily used. Kind of get that more natural. It's about the right size, let's just say, for this, the space that you're typically recording in. Yeah. Yeah, because all the other ones kind of sound.
Reverse reverb.
Oh, I forgot the. Okay. What you're hearing is a reverse reverb, and in the reverse reverb, the reason why it sounds like almost kind of a delay is because instead of having the early reflections come first and the massive reflections come second, they have the massive reflections come first and the early reverb comes second. So there's almost a delay at the tail end of the verb. Does that make sense? And it grows instead of diminishing on its way through. So
Gated reverb.
this is the gated reverb. You hear it close it real quick. Still big and long, but it goes quick.
Will you play the reverse again?
Yeah. No. Oh shoot.
Uh,
Hold on, let me see if it'll let me to do this individually. Oh, there we go.
Reverse reverb.
More, it might be more easily identifiable. Let me bring in a DAW to help us. I think it more be identifiable with drums, just because when you have a transient, you can clearly hear when the transient begins and how it ends and how it closes. Did you have a question? Sorry, no. Okay, so let me bring in. Let's see. Actually, I could just do one of these. Let's switch kits. Let me turn this up for you. All right, this has a reverb on it already, but let's go take a look. It's in the mixer. Actually, let me bring something up. Oh, where did I put it? So I think I showed you this a couple weeks ago. What I'm going to do is, it's kind of an unfair advantage with this, because some of this stuff I actually recorded on Reverb space. Let me go to the guitar. Here's a guitar dry. A little bit of something on it. Here goes a plate verb. Sorry, it's a little sloppy. And then here is a room. Now, what a lot of times you like to do is kind of bury it, bring in the reverb, kind of let it sit in the right mix. What you'll notice when this other one comes in. Well, it's because technically it's adding gain to the mix. So it brings in that, essentially it brings out that kind of thing. So I put in this, crazy slide guitar thing, and if I remember correctly, There's a bunch of reverb directly on it. See if I can find it. It's in here somewhere. It's in here somewhere. Oh, I think this is it. Oh yeah, so what I did with it is, you know, I mean, you can kind of see it here. This is I put a distortion unit on it, and then I went and I put this echo unit on it, and on this echo unit, I'm using this space reverb patch, which is just it kind of gives it that quirkiness to it, which is why it kind of has that sound. And then I added a multi-tap delay on top of it. But you can see this is the echo reverb. You can see the diffusion properties here, and you can actually change the overall color. There's also a filter frequency, so you could focus in some of the filter aspects. And you can add, in the echo, you can add a little bit of independent delay. But I mean, invariably what this does is it gets that overall sound that you hear. But if I go and show the additional devices, I also have, so in addition to this, I also have a standard guitar reverb. In this one, you can just see it's just the basic decay. The high frequency dampener is, again, rolling back some of the high frequencies. And the overall high EQ is turned down just a touch. Now, the big thing that we didn't see that we also need to talk about is dry versus wet. It wasn't in the slides, but I do want you to write this down. So dry versus wet. Okay, dry and wet.
Is this part of dampening or different?
This is part of reverb. This is a parameter of reverb. I mean, it's a parameter of effect, a certain line of effects. What they call timing effects, which includes reverb, delay, any sort of echoing, chorus, flange, things like that. Dry versus wet, essentially what happens is signal is brought into the device, and if it was blended all dry, that means only the raw signal gets put out. If it's blended all wet, it means 100% of the reverb is being used without the dry signal. If you were to do 50-50 down the middle, which is why you see this knob says dry versus wet, you do 50-50, essentially it's down the middle, it's essentially dry and wet, a combination of the reverb and the dry signal. And you may be asking, well, that's kind of weird, so why would they build it in a way where you have to either elect to have it blended more or blended less? A couple of reasons why it exists the way that it does. One, it gives you the ability to decide, let's just say, okay, I have this reverb unit over here, right? So I have this reverb effects engine here, and it's kind of how it's basically this device, at a very basic version of this device, but here is a rack-mounted effects reverb effect. What happens is if I had to, because of routing, if I don't have the ability, and we're going to talk about sends, that's the next thing we need to talk about today. If I don't have the ability to split my output, my initial source, split it and send it here independently, then I have to run my original source through the effect. If I run the original source through the effect, more than likely I don't want it to be 100% affected. I still want some resemblance, or the majority of resemblance of the original signal. So that's why I would blend it more dry. If I was being like in this instance, I was being kind of crazy with this guitar sound, so I just kind of wanted to go, hey, let's just go nuts with this. Let's add a lot of reverb and do a little bit of a different sound. And by doing so, that's kind of where that sound came from, and it required me to go 100% wet. But in most instances, if the effect is set up on an effects chain and it has its own separate path, what happens is the signal, the original source signal, will go down the channel. You guys with me still on this? It'll go down the channel. The original signal will come out of the fader. And then we'll split an additional signal to send to the effects unit so that we can have a separate signal to blend with on the other end. And that's how we get to have everybody on here be in the same reverb or the same effects unit. Otherwise, it would be impossible because everybody would be routed directly through an effects engine. This effects engine is in stereo and only has 2 channels in, 2 channels out, which means that if I was to route through it, I could only route 2 channels in and 2 channels out. But if I wanted to have it sent to just one reverb, I'm going to show you this in a second, so maybe I'm talking ahead and maybe you guys are kind of like, I don't know what he's talking about. But I wanted to show you this, at least this example here. Let me show you what this guitar sounds like dry real quick. If I can go back and find where that spot was. It's here. Oh, whoops. Wrong move. There we go. So this is the effect. I'm going to bypass it real quick. Almost there. There we go. So this is the dry effect, the dry guitar. I mean, it's literally just. But again, you go in and add all that verb, and it really gets that sound. And the distortion. So that's kind of how that works. So, you know, I mean, this is kind of a really heavily blended element. So I can actually show you this on here. It might be easier to show you here, and then we'll break out to actually using the mixer down here. So there's a mix unit up here. And in the slides, although I kind of lost where we were. Oh, yeah, here we go. There's just a couple things, and I'll kick back to this. Aux Sends. You might want to jot this down. This is going to be important for you to understand. Auxiliary sends. Aux Sends. And if, you know, when you're in Pro Tools, it's still essentially an aux send, but they call it bus sends because you can use them in different ways. Some mixers call them omni sends. Essentially, it's a send. And in this instance, an aux send is literally a split of the original audio that's sent off its own individual volume knob. And so what happens is on this console, you can see the aux sends on this console are these 4 channels here. This whole row, these are all aux sends 1, 2, 3, 4. And they all have their own volume that comes from the gain. So like once you set your gain volume, these volumes can be independent. We'll talk about that next, and I'll show you how this works over here. The purpose of having aux sends is they're used for things like reverb, delay, effects, and they're also used for monitoring in the studio or live on stage. So like if I wanted to give you a headphone mix of what we're recording right now, I'm going to have to use an aux send. Okay? I could use the stereo mix, but the problem is the stereo mix isn't tailored to what you need to hear. It's tailored to what everybody needs to hear in the control room. A lot of times, like when how many of you, anybody recorded in the studio before? Okay, so in most cases, when you're recording in the studio, you're going to put on a pair of headphones, and life is going to get real small feeling. So what we have to do on the other side of the glass in the control room is create a monitor mix for you to feel nice and comfortable, like you're still playing live, or you're still, you know what I mean? Like it's not just you in this little room, it's you with everything else that's going on. So in order to do that, we need to give a mix that's tailored to your liking. So a lot of times, like you'd be really surprised. Like a lot of musicians need, you know, a lot of times they'll need this or that. I mean, some guys will go, and I've been on stage for a live mix, and the guy's like, I don't want to hear that person. I don't like what it sound like. I only want to hear that, you know, I only want to hear the kick and the snare, and that's it. You know, when I was playing live, most of the time, I just needed to hear a little bit of the drums and then the vocals. And, you know, even if we were like this far apart and the other guitar player's over here, it's like, I already know what he's playing. I'm really confident in what he's playing. If something goes wrong, he'll give me a signal or I'll see an expression on his face. But for the most part, I'm going to trust that he's doing what he's supposed to do. My job is to lock to the drummer. If I lock to the drummer and he locks to the drummer, then technically we should be locked to each other. the problem is on a live stage, if I get too much monitoring and too many volumes of other things, everything gets kind of lost, and then I get kind of lost, and it gets confusing to hear the thing that I really need to hear. So a lot of times in the studio, what happens is most musicians, if they're playing to a click, a lot of times it's click they need to focus on. If they're playing to a drummer or they're trying to play to a specific thing, they need the monitors to focus on something specific. The greatest part about having these sends is that I can set up your mix on the sends, and once I set it up, I can do whatever I want in the studio and solo and change things that I want to hear without it affecting you. And that's kind of the beauty of the way that the sends work. Again, I'm going to show you this in just a moment. Two things you do need to know about sends. These are huge. Pre-fader, post-fader. We talked a little bit about pre-fader and post-fader when we were originally talking about the mixer. Remember the day we brought out the block diagram and it had all these chains of signal, and I said, hey, here's pre and here's post. This is where it matters, is when we talk about pre-fader signal for the sends. Pre-fader signal for the sends, the volume of the send is not affected by the volume of the fader because essentially the pick point, what we call a pick point, but essentially it just means that we steal the signal. So remembering that when I have a send, I'm splitting the signal, right? So original source signal is split in two. It just means on a pre-fader, it just means that the signal is split here. It's not split after here. Which means I can do this all day, and if I said, hey, this volume's going to go up to, number 3 here, that volume essentially will not be affected or changed by the fader. Pre-fader, right? Pre-fader, not affected by the fader volume. It's good for monitoring mixes, monitor mixes and special effects. It's great for monitor mixes because if I set up a monitor mix, like we took 5 minutes to say, hey, what do you want? What do you want to hear in your mix? Let me give you this, this, and this, this. And you're like, oh, I love it. Sounds great. I feel confident with what I'm hearing. And then for some reason I decided to change the faders, all of a sudden it would wreck your monitor mix if it wasn't set, if it was in post-fader mode essentially. So pre-fader mode is good because I can set it and it won't affect you if I make changes here. Make sense? Yeah. Also in pre-fader mode, the other thing you could get to do also is you can, and on some mixers, you can actually mute the channels. So if there's stuff you don't want to hear when you're in there, I mean, think about this. You as an engineer, if you're going to be an engineer in the studio, you're going to hear the same content for many, many hours. So maybe you don't want to hear this, or you don't want to hear that, or you want to focus on how tight this is to that. I mean, I've been in the control room where it was like, maybe the guitar player's in the studio playing, and they want to hear just how well he clicks and connects directly to the bass player, but he wants to hear the drummer more than anything else. But in there, let's just solo bass and guitar. I just want to hear how well they jive, so we can really hone in on it and help produce them on that side. So having those two separate mixes really helps. So ideally, however many sends you have, those are all additional mixes that you get to have for monitoring while you have your own, like this is your mix at the faders, right? Does that make sense? Yeah. Follow me so far? Post-fader sends, of course, are the volume of a send that is affected by the fader. And so that would be if you did set it up and it was affected by the fader. The reason that is beneficial is specifically for general effects. And the reason why it's good for effects is because, let's say I put a certain amount of reverb, I'm sending a certain amount of reverb down a send, and the reverb, think about this, when I use a reverb as a send, the blend, let me just start by saying this. When I use a reverb as a send, the effects are 100% wet. Like the effect unit has to be set to 100% wet. What's going to happen is I'll send to a reverb that's 100% wet. And then what happens is, this is of course just my natural path, so this will be 100% dry. So here's 100% dry, here's 100% wet, which means that if I give them a blend of even balance between the two, it makes a 50-50. And what I get to do is if I'm in pre-fader mode, I can literally just blend however. I could turn this all the way down and turn this all the way up, or it doesn't have to be all the way up as long as it's sending. All the way down and all the way up, that's 100% wet in the final outcome. If I turn the send all the way down and this guy back up, it's 100% dry in the final outcome. And then again, anywhere in between is a blending of the two. But if I move it to post-fader, maybe I do want it to be blended, but I want to use post-fader so I have a nice little blend of it. What I get out of it is when I decide, hey, this is going to get a nice smooth fade out. When I fade it out, the balance between the original dry and the wet signal will fade out together. If I were to go pre-fader, you guys follow me? If I were to go pre-fader, when I fade this, my send is still rocking. Which means my reverb level or effects level just stayed. which isn't good. You know, you don't necessarily want to have to turn both of these down at the same time and try to guess that they're well blended. Does that make sense? I'll show this to you in working practice here. You guys got this definition, right? Nothing too bad. Let's see, what do we got? Actually, let me see. Let me bring in a different one. I'm trying to remember if... Okay, let me get that. Actually, here's what we're gonna do. It's 4 o'clock. Let's turn over. We'll do some work with this the console in a lab form. Kind of show you how this works out with the sends. So what we'll do is let's take a 5-minute break. When we come back, remind me to hand out the homework.
Alright.
Is that cool? So we'll take a quick 5-minute break. I'll reroute the system so that it's ready to go, and then we'll jump back into this. Cool?